Let's automate your data platform deployment. Welcome to this focused training session. This means we will be diving deep into one specific, powerful workflow using Terraform to automatically build a complete Databricks environment on Amazon's cloud platform. Instead of broad theory, we are going to get hands-on, walking through the exact steps to turn infrastructure code into a running system. So what does it mean to automate Databricks deployment? Instead of manually clicking through a web console, you will write code that defines your entire Databricks workspace, clusters, and security settings. This code, written in Terraform, becomes your single source of truth, allowing you to reliably and repeatedly spin up identical environments on AWS with a single command. Now, to automate this deployment, we will combine Terraform's power with AWS. Think of Terraform as your blueprint architect, writing the exact instructions. AWS then provides the raw materials, the compute, storage, and networking. This combination lets you build your entire Databricks environment, from virtual networks to clusters, in a repeatable, documented way. Now, combining Terraform's power with AWS allows us to achieve consistent, repeatable infrastructure. This means every time we run our deployment, whether for development, testing, or production, we get exactly the same environment. We eliminate manual steps and configuration drift, so our Databricks workspaces are reliable and built from a single source of truth. Let's begin this practical journey. Now we will roll up our sleeves and actually build something, moving from theory into hands-on practice. You will see how to define your infrastructure as code, execute the Terraform commands, and watch your Databricks workspace come to life on AWS in a reliable, automated way. Ever wondered how to automate your entire data platform? Now, Terraform defines infrastructure as code. Instead of manually clicking in a cloud console, you write simple, declarative configuration files. This code describes exactly what you want built, like a network or a Databricks workspace. Terraform reads this plan and makes it a reality, ensuring your infrastructure is consistent and easily repeatable across any environment. So, Terraform defines our infrastructure, but AWS provides the cloud platform where it all runs. Think of AWS as the massive, global data center that supplies the raw computing power, storage, and networking, all the physical resources we need. When Terraform runs, its instructions are specifically for provisioning and configuring these services within the AWS ecosystem. Now, Databricks offers a unified analytics workspace. Think of it as a single, collaborative hub where your data engineers, data scientists, and analysts can all work together. Instead of juggling separate tools, they can manage data, run machine learning experiments, and build dashboards in one integrated platform, all powered by the AWS infrastructure we just mentioned. Now, the bullet tells us that Terraform automates provisioning on AWS. Instead of manually clicking through the AWS console to set up networks and services, you write a declarative configuration file. Terraform reads that file and handles all the API calls to build out your exact Databricks environment on Amazon's cloud, ensuring consistency every single time. And it ensures version-controlled, reliable deployments. So, think of your infrastructure setup, like networks or security groups, as code saved in a file. Every change is tracked, just like an application update. This gives you a single source of truth, making every deployment repeatable and consistent so you avoid those "it worked on my machine" problems. Let's move from theory to actual results. So, we define our resources in Terraform configuration files. Think of these files as your blueprint or shopping list. You declare exactly what you want built, like a Databricks workspace or an S3 bucket, using a simple, human-readable code. Terraform then reads this file to understand your entire desired cloud setup. Now, you define your resources. But the real power comes in managing these core cloud components. With Terraform, you can provision your entire virtual network, the VPC, then lock it down with security groups, and finally, define precise access permissions through IAM roles. It's about creating a secure, well-architected foundation for your data platform, all from code. Now, we use the Databricks Terraform provider. This is a specific module that lets you directly define and manage Databricks resources, like workspaces or clusters, within your Terraform code. Instead of manually clicking through a web console, you can codify your entire Databricks environment, ensuring it is reproducible and version-controlled alongside your AWS infrastructure. Now, we use the Databricks Terraform provider to plan and apply changes safely. Before any infrastructure update, you run a Terraform plan to see exactly what will be created, changed, or destroyed. It is a dry run that prevents surprises. Only after you review that output do you execute Terraform apply to implement those changes with confidence. Now, we move from planning changes to automating them by integrating with CI/CD pipelines. Instead of running Terraform commands manually, tools like Jenkins or GitLab CI can automatically apply your plan whenever you update your code. This ensures your infrastructure is always in sync with your repository, making deployments consistent and repeatable for the entire team. Let's review what we have built and look ahead. Alright, so you now understand the deployment approach. That's a huge step. You have seen how the process flows, from preparing your code all the way to getting it live on SAP BTP. This gives you a clear map to follow for your own projects, turning theory into a practical, repeatable set of actions you can take. So, you know the deployment approach. Now, Terraform brings automation and consistency. This is huge. Instead of manually clicking through the console for every environment, you write code to define your infrastructure. That same code can reliably deploy your development, testing, and production landscapes, ensuring they are identical. It automates the repetitive work and eliminates configuration drift. So, AWS provides a scalable foundation. While Terraform automates your setup, it needs a reliable platform to build on. AWS delivers that with virtually limitless compute power and storage. This means your SAP BTP solutions can grow seamlessly, handling more users or data without you having to redesign your entire infrastructure from scratch. Now, start automating your deployments today. We have just seen how AWS gives you that solid, scalable base. The next logical step is to stop doing things manually. Think about using tools to automatically build, test, and roll out your applications every time you update your code. This saves a huge amount of time and makes your whole process far more reliable and consistent from the very beginning. And with that, our journey through practical automation wraps up. A huge thank you for your participation and attention throughout this session. I hope you are leaving with a clear path to implement these strategies in your own projects. This is where our video ends, so thank you for watching, and I wish you the very best with your deployments.